In this example, we're going to graph the linear inequality y is greater than or equal to 3/2 x minus 4. So the first thing that I notice is that this linear inequality is written in slope-intercept form, and that's helpful because I need 4 pieces of information to graph this linear inequality. 2 of them are the slope and the y-intercept, which I have right here. So m, or the slope, is going to be 3/2. That's the coefficient of my x variable. My y-intercept, or my b value, is -4, or you could write it as an ordered pair, 0, -4. So the other 2 pieces of information I need to know whether this is going to be a solid or a dashed line, and since y is greater than or equal to, we have this equal to bit, which means it's going to be a solid line. And when I draw my line, it's going to separate my coordinate plane into 2 regions, and the line will be the boundary between those 2 regions. And this equal to indicates that the boundary itself will be included in the solution set. And then its y is greater than or equal to, so I know I'm going to shade above my solid line. So let's go ahead and get going graphing this. So I'm going to start at 0, -4 for my y-intercept. And I'm going to use my slope 3/2, or rise over run, to plot some additional points. Up 3/2, up 3/2. It looks like I'm going to do it one more time. Okay, so here are my points. So let's grab a straight edge here and go ahead and draw this solid line that's going to be between these points. Okay, put the arrows there. So finally, I have y is greater than or equal to, we mentioned before that's going to be shading above the line. So I know as far as the y-axis is concerned, we're going to be shading above the y-intercept, so we're going to be shading this region right here. But another way to kind of verify that is by using a test point. 0, 0, the origin, is a perfect test point as long as the linear inequality itself does not pass through the origin. So I notice this line does not. So I'm going to go ahead and do a test point 0, 0, and I'm going to plug 0, 0 into my inequality, and I'm going to see whether it's a true statement or a false statement. So 0 is greater than or equal to, well, when I plug 0 right here, this whole thing goes away, so I just have a -4. So is 0 greater than or equal to -4? Well, sure it is. Okay, so since I know that bit is true, I'm going to go ahead and shade on the side which includes the origin as an ordered pair, which will go ahead and be this right here. So as we see here, we have the graph of this linear inequality. Y is greater than or equal to 3/2 x minus 4.